The bending moment m of a simple beam used in bridge construction is given by this formula here. M equals WL over 2x minus W over 2x squared. If L equals 13, W equals 16, and M equals 288, calculate x. So this x, finding x is the question. So if we look up here, we can see the highest power is 2 in the formula. So this tells me this is a quadratic. How do we solve quadratics? Well, it's a quadratic equation, so we're going to let the equation, or rearrange the equation so that it equals 0. And that's how we solve it, and we factorize, etc. So first of all, we've got these letters. We need to substitute those numbers in, so we'll do that first. Okay, so here I've just substituted. Where I saw M, I put 288. Where I saw L, I have put 13, and W 16, etc. So we get this equation. So we can obviously multiply that 16 by 13 out and all that. So if I do that, we've got 288 equals, so 16 times 30 is 206 over 2 minus, now I could simplify 16 divided by 2, so I'm going to do that now, and I'll do that there. Alright, I can simplify further. I can divide that 206 by 2, so we'll do that too. So I get, whoops, I've forgotten the x there, I put it back. So we get 288 equals 1. Okay, so actually 16 times 13 is actually 208. Sorry, I'll fix that up for you. Okay, so let's start again for that bit. So 16 times 13 is 208 over 2x. So that ends up being 104x, and we've got the 8 squared over here. So here we've got this quadratic equation. So I'm going to move everything onto one side so that I have it equaling 0. So I'm going to move these that way over the equal sign, because I don't want to work with a negative, so I'm going to do that. So if I move that over here, I'm going to get a positive 8x squared. This one would become a minus 104x, and I didn't move the 288, so it's still positive, and I'll let it equal 0. So now I'm happy. Let's go through our factorizing. We'd find a common factor. So a common factor in this is 8. So if I take 8 out, I'm left with x squared minus 13x plus 36 equals 0. So then I'd be looking at this. Is there any patterns? That is a squared number, so which would be 6 squared is 36. But is this 2 times 6 in here? No. So we're not. So it's not a pattern. Not pattern. So I'm going to use the cross method. Okay, doing the cross method, we're going to look for factors of x, which is obviously x squared. This is an x and x. Now factors of 36, but they need to add up to negative 13. So I need to get 2 negatives, and that'll add up to, so I'm going to try, so negative 9 times negative 4. So you can see that if we go x times negative 9, we get negative 9x, and x times negative 4, we get negative 4x. If we add those two, that would give me this number here. So I'm happy with that. So my factors now have become 8, and x minus 9, and x minus 4 equals 0. So therefore x, using the null factor law, x could equal 9, or x could equal 4. So we've got 2 answers here, and that's okay. We'll keep that and we'll write that. It said calculate x, so we go x could equals 4 or 9, and you're done. Okay, a polygon with n sides and n outside n minus 3 over 2 diagonals. So sorry, these are the formulas for this particular polygon. How many sides has a polygon with 65 diagonals? So because that is the formula for diagonals, we're pretty much saying that that equals 65 in this scenario. So we want to know how many sides, this how many is, well, really we're finding n. Okay, so we'll put in the information we've got. So we've got 65 equals n minus 3 over 2. Now, you can see this is a quadratic, because if you expanded that out, n times n, you get an n squared. So the highest power is n squared, so therefore we know it's a quadratic. So we want to go about solving this. So a quadratic, we solve by letting the equation equal 0, but probably best we expand this out so we get that n squared and all that. So let's have a look. We'll do that. So we get 65 equals n squared minus 3n all over 2. Now, it doesn't look like our polynomial form, this form, the ax squared plus bx plus c. So let's try and make it like that. So I'm going to move the 2 over this side. So that'll be 65 times 2 equals n squared minus 3n. So now I have 130 equals n squared minus 3n. So I'll keep going to make, now it's in a quadratic equation, so I want to let one side equal 0, so I might move this 130 that way. So I end up with n squared minus 3n minus 130, and I have another side equaling 0. Okay, alright, so here we go, we got a quadratic. We look for the patterns, that's not a squared number. So let's go with the cross method. Factors of n squared is n and n. Now factors of negative 130, and we want a negative in there, so how about we go negative 13 by 10, n times negative 13, negative 13n, n times 10, 10n, they add, beauty, here's the brackets. So we've factorized it now, so we have n minus 13 and n plus 10 equals 0, so therefore we found that n equals 13 or n equals negative 10. Now, can we have negative sides? No. So that's not an answer. Therefore, this n equals 13, we can have positives. So the polygon has 13 sides. Cheers.